Hello, fabulous pre-cal students. Today, we're talking about doing some things with polynomials. We want to first ask, what is a polynomial? Then we want to add and subtract them. And then we want to multiply them in all kinds of different ways. Many of you will find this really, really easy. And that's the way it's supposed to be. This is supposed to be your easy, fast homework. Okay? So, let's start with what is a polynomial. I think many of you have a sense of this word already. So, let me try. Y equals x squared plus 3x minus 4. Is that a polynomial? What do you think? Thumbs up, thumbs down? Thank you for raising your thumbs while you watch this video. Good. Yes, this is a polynomial. How about this one? 3x minus 4. Is that a polynomial? Yes, it is a linear function, but it's also a polynomial. This is a yes. How about y equals negative 4? Or y equals 3x? Are these polynomials? And many people say no, because they say, Mr. Kukla, I haven't had Greek yet, but I know that this Greek prefix means many, many terms. And this is not many terms. This is one term. This is one term. So these are not polynomials. And it turns out, yes, they are. Because in math land, we have a definition, a mathematical definition for what is a polynomial. A polynomial is anything that can be written in the form, and now I'm about to write something down which is going to scare many of you, so don't be scared. Trust me. Okay, a to the n x to the n plus a to the n sub 1 x to the n minus 1, and that pattern continues for a long time until we have a sub 2x squared plus a sub 1x plus a sub o. This is the form for a polynomial. Now, these subscripts, they're not powers, they're names. This is, hi, I'm the number in front of x to the first. Oh, me? I'm the number in front of the x squared power. I'm the number in front of the x to the nth power. So what we're saying is polynomials A can be infinitely long, and they can have numbers in front of the variables raised to powers. And usually we go from our highest power down, down, down to our lowest power, and this is x to the 0 here, okay? Now, since these are numbers, what if I made all the a subs 0 until I got to here, when I made a sub 2 equal to 1, a sub 1 equal to 3, and a sub o equal to minus 4. Then I would have x squared plus 3x minus 4. Hey, we saw that polynomial. And then, what if I wanted to make this polynomial 3x minus 4? Well, we'd have a sub 1 being 3, and we'd have a sub o being negative 4, and we'd make all the other a subs into 0, and we'd be left with these. Well, what happens if I make all these coefficients 0 except this one? And I said, well, let's make a sub o equal to negative 4. These would all disappear because they would be 0 times something, and the only thing I'd have is that. So it turns out a polynomial can, in fact, have one term to it. What can't a polynomial have? Well, we said it had to be written in that form. So how about x squared plus 3x minus 4 over x? Well, is this in that same form? Think about this for a moment. X squared plus 3x minus 4x to the negative 1. So I flip that back up and turn x into the negative 1. When we looked at that general form, dot 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 a sub 2 x squared plus a sub 1x plus a sub o x to the 0. Did we go past into negative land? No. So polynomials don't have negative exponents. They don't have x's in denominators. Anything else that we can say? Well, yeah. It turns out that polynomial powers are all whole numbers. And so we can't have something like x to the 2/3 plus x to the 1/3. Yeah, no. No, they don't have rational exponent powers. Okay? So, let's test your knowledge of polynomials. Okay? Is this a polynomial? Y equals x squared plus 3x minus 4. Yes, this fits in that form. We're good to go. We even have it in descending order. How about y equals x squared plus 3x minus 4 over x? No, because we have an x in the denominator. How about y equals 2x plus 1? Yes, that fits our form. How about y equals 2 square root of x plus 1? No. No rational exponents. This is x to the 1/2. Okay? How about y equals 3? Yes, that works. It's a linear equation. It's kind of a naive polynomial, but it's technically a polynomial. All right, so if we see something like y equals x to the 2/3 plus x to the 1/3, we can just say no, that's not a polynomial. How about y equals x squared plus x to the minus 2? No, that's not a polynomial because we can't have negative exponents. How about y equals x squared times x to the minus 2? Well, be careful here, because when the bases are the same and we're multiplying, we can add those exponents. And we get x to the 0, and that's 1. Y equals 1? Sure, that's a polynomial. It didn't look like a polynomial. I mean, I'm used to seeing x squared plus 5x plus 6 and saying, hey, that's a polynomial. This doesn't look like a polynomial, but it can be simplified into something that is a polynomial. Okay? All right, and oh, how about this one? Y equals root 2x plus 1. I'm not likely to give you this on a test, but this is legit. This is a polynomial because we have x not to a fraction-y power. Radicals are okay on the coefficients. I can't have radicals in the denominator. I mean, in the exponent position. So this is a polynomial. Okay? All right, so we talked about what is and what is not a polynomial. You'll see some of those to do in your homework. Now, what about adding and subtracting? You've been doing this for a while, so I'm just going to lay out problems for you, and then you can show me how to do it. 2x squared minus 3x plus 1. Okay, take a minute to add these two polynomials together. Okay, welcome back. So the first thing I do is I want to get rid of these parentheses, so I'm going to distribute that positive throughout. So 3x squared plus 4x minus 7 plus 2x squared minus 3x plus 1. And then I combine like terms. And that's it. Okay? Really, it's just combining like terms. the biggest thing we have to worry about is what happens here with subtraction. That's where I notice people make mistakes, because this is a distributing opportunity. You need to distribute this negative to each of these. And a lot of students distribute to the first one and forget the other two. And so then they get the problem wrong. So watch out for that. You might want to put that in your notes to watch out for distributing mistakes. Negative times negative is positive. Negative times positive is negative. We're still going to combine like terms. 3 of these minus 2 of these leaves me 1 of them. 4 of them plus 3 of them will be 7 of them. And minus 7 minus 1 will be minus 8. Okay, so you can do the next two. How about 15x to the 4th minus 3x squared plus 1 plus 2x to the 3rd minus 5x squared plus 3x. All right, please add those to polynomials. So, did you end up with 15x to the 4th, because there were no other x to the 4ths, plus 2x to the 3rd, because there were no other x to the 3rds to combine with, minus 3 minus 5 is minus 8x squared, and then plus 3x, because there's no x to the firsts here, and finally plus 1. That's it. That's our polynomial. That's all we can do. When we add these two polynomials, we get a polynomial, and there's not much we can do with it except, hi, polynomial, good to see you. Okay, so here's your last adding and subtracting one. 3x to the 3rd minus 4x squared minus 5x plus 6 minus 2x squared minus 5x plus 7. All right, pause the video, do this subtraction of polynomials, and come back when you're done. Welcome back. So I've got x to the 3rds here, and I don't over here, so I know I'm starting with 3x to the 3rd. Minus 4x squared minus 2x squared is minus 6x squared. Minus 5x minus a minus 5x is going to be minus 5x plus 5x, and so my x to the 1sts cancel out. And then 6 minus 7 is negative 1. All right, so there we go. We reviewed adding and subtracting of polynomials. And the last thing we need to talk about today is multiplying polynomials. Okay, so let's start with some multiplying. Will you multiply this polynomial times this polynomial? See that binomial, 2 terms, is a polynomial, and that binomial is also a binomial, 2 terms, and so I'm talking about multiplying 2 binomials here, which are specific types of polynomials. Will you please do that and show me what you get? Welcome back. So I've got x squared plus 3x minus 4x minus 12, or x squared minus x minus 12. Okay? We should be very comfortable with our foiling at this point in our math career. How about 3x minus 5, 2x minus 1? Okay, give that one a try. Okay, welcome back. So I know that this is going to be 6x squared, because 3x times 2x, 3 times 2 is 6, and x times x is x squared. Then I have 3x minus 1, which is minus 3x. Then I have negative 5 times x, which is negative 10x. And negative 5 times negative 1 is plus 5. When I combine these like terms, I end up with 6x squared minus 13x plus 5. Okay, and in our next video, we're going to go from this polynomial into its factored form. But for now, we're taking this uh, factored form of a polynomial and foiling it to get back to our original polynomial. This is actually going to be the way that we check our factoring. All right, so how about this one? 2x plus 1, 2x minus 1. Please FOIL that out. Okay, welcome back. Hey, I noticed something strange here. 4x squared minus 1 is my answer. I thought when I multiplied two binomials together, I was always getting trinomials. You know, like when we had x minus 3 and x plus 4, we ended up with x squared plus x minus 12. 3 terms. Why am I only getting 2 terms here? Is that a problem? Did I make a mistake? Well, let's try the FOILing. 4x squared minus 2x plus 2x minus 1. These middle terms are opposites, so when I combine like terms, the middle goes away. This is that difference of squares we were talking about when we were doing conjugates. When we have a difference of squares, i.e. something squared minus another thing that's been squared, right? This is 2x being squared minus 1 being squared. When we have a difference of squared things, they're always going to factor in the same form. And that will always have only 2 terms. We won't have 3 terms with our difference of squares. All right, so don't confuse that, though, with this. This is not a difference of squares. A difference of squares has to have a plus and a minus. In this situation, the middle term goes away. But in this situation, the middle term does not go away. I need to do my FOILing here. When I FOIL, x squared minus 2x minus 2x plus 4. The middle terms do not cancel out. Instead, I have minus 4x plus 4. Okay? Don't be afraid to FOIL this stuff out. Don't rush through it and guess your answer. That's the biggest type of mistakes that people make here are sign mistakes in FOILing or in distributing. All right, so what are you going to do with this one? X minus a times x minus a. Would you please multiply those two polynomials together? Okay, welcome back. Did you get x squared minus ax minus ax minus a minus is plus a squared? And then combine like terms. One of them minus one of them minus one of them minus one of them is minus 2 of them plus a squared. That's my answer. So don't be scared if this isn't a number. Just do your regular FOILing. All right. So what about this situation? ax minus b, ax plus, minus b. Please FOIL that out. Please multiply those two binomials together. That's right. We end up with a squared x squared minus 2abx plus b squared. Now, there's something interesting here. There's a pattern. So, and some of you may be interested in this pattern. The answer is the first term squared, the second term squared, and then the middle term is this times 2. Again, if you're looking for a shortcut here to avoid FOILing, it's this one is squared, this one is squared, and the middle term is this times 2. That's why we have that negative there. It comes from that. Okay? So if I see something like 2x plus 3 times 2x plus 3, I'm going to do the same thing. This is a perfect square trinomial. This one squared, this one squared, and the middle term is this times 2 plus 12x. So if you like that pattern, you can definitely use that pattern. Two of the same, two of the same. First one squared, last one squared, middle term is this times 2. Okay. And likewise, we have that same pattern when we have one of each. This one and this one. This is our difference of squares, and we know that's going to be this times this, or this one squared, minus, because negative times positive is minus, this times this, b squared. We know those middle terms are going to cancel out. So we just have the first one squared minus the second one squared. Okay. So what about x minus 1 to the third? Is that going to be x to the third minus 1 to the third? Cool little time. No, that's not it. That's pool needle time. You cannot apply that exponent because of this plus or minus in here. This is a foiling situation, okay? This is x minus 1 times x minus 1 times x minus 1. That's what this means. So let's show what it really is. First, I'm going to FOIL these together. And that's going to give me x squared minus 2x plus 1 times this x minus 1 over here. And now, ooh, look, a trinomial times a binomial. It's not quite foiling anymore, but I can multiply this x squared times each of these, and that will give me x to the third minus x squared. And then I'm going to multiply this negative 2x times each of these, and have negative 2x squared minus a minus is plus 2x. And then finally, I'm going to multiply this times each of these with a color that actually writes. And so I'm going to have x minus 1. Now I can combine my like terms. Ooh, look. Oh, there's some more. And so I end up with x to the third minus 3x squared plus 3x minus 1. Now look, those of you who said, isn't this going to be x to the third minus 1 because you were applying the exponent to each of those, which I said you could not do, look what our answer really is. Yes, I have x to the third. Yes, I have the minus 1, but yeah, I don't have these two middle terms that I'm supposed to. So when you see that 3 up there, you need to FOIL. You need to FOIL. Please FOIL. Okay, so will you FOIL here? 2x minus 3 to the third. Pause the video. Take a minute to try that out. Okay, welcome back. So I hope you thought about it as 2x minus 3 times 2x minus 3 times 2x minus 3 and started by FOILing two of them together. So this would give us 4x to the second minus 12x plus 9 times 2x minus 3. So now I have to multiply this times each of those. It's going to be 8x to the third minus 12x squared. And then I'm going to multiply this times each of these. So that's negative 24x squared plus 36x. And finally, I'm going to multiply this times each of these. And so we get plus 18x minus 27. I need to combine like terms. Here are some, and here's some more. 8x to the third minus 36x squared plus 54x minus 27. Ta-da! We can multiply polynomials together. What about this trinomial times this binomial? Pause the video, give that one a try. And then we'll just do one or two more problems to wrap this up. Okay, did you end up with 2x to the third minus 6x squared minus 5x squared plus 15x minus 2x plus 6. And then when you combined like terms, did you have... And ideally, this problem takes just that long. But it's not a really long, laborious process. It should have been a long process in 8th grade or in Algebra 1. But by now, we should be able to get through this quickly as well as carefully, right? Don't make sign mistakes. Pay attention to those. I will say sign mistakes were a really common type of mistake last year for students, and guess what? It's still going to be common for people to make sign mistakes. Okay, the last thing I want to look at is what happens when we multiply two trinomials together. And so we've got to multiply this times each of these. So that's going to be 3x to the fourth minus 12x to the third plus 15x squared. And then I need to multiply that 2x times each of these. So I'm going to have 2x to the third minus 8x squared plus 10x. And then I have to multiply this 1 times each of these, which is going to be 1x squared minus 4x plus 5. And you'll notice the way I wrote this was not in one long line. I actually stacked common powers together to make it a little easier to combine like terms. 3x to the fourth minus 10x to the third. 16 minus 8 is 8x squared plus 10 minus 4, 6x plus 5. Okay? All right, your turn. Last one. Show me you're comfortable with this standard by multiplying 2x squared minus 3x plus 4 times 3x squared minus 5x plus 4. Okay, pause the video, give this one a try. Strive for no mistakes, but also strive for, getting it done. Don't complain about it. Wow, oh no, I don't want to multiply this, how it's going to take so long. Yeah, all that whining is taking time and energy when you could already be done with the problem. All right, welcome back. So I've got 6, I got a red marker there. Almost at 6, yeah, no. 6x to the fourth minus 10x to the third plus 8x squared. And I have minus 9x to the third plus 15x squared minus 12x. And finally, 12x to the second minus 20x plus 16. So if I combine like terms by adding down, I end up with 6x to the fourth minus 19x to the third plus 27, 35x squared minus 32x plus 16. All right, so there you have it. We reviewed working with polynomials. We first defined what a polynomial was. Polynomial, any number of terms, no negative exponents. What else? What else can't a polynomial have? We know it can have 1 term, 2 terms, 3 terms, or many, many terms. But what can't a polynomial have? No negative exponents, no rational exponents. That means no fractiony. But it feels bad saying fractiony. I'd much rather use the proper word, rational. Okay? So look for those and say, hey, you're not you're not a polynomial. Then we talked about adding and subtracting polynomials. And we said here that watch out for distributing mistakes. I'm sorry, combining. Yeah, distributing mistakes, because it was when you distribute that negative in the subtraction that some people make mistakes. And other than that, we're just going to combine like terms. Okay, So then we talked about multiplying. And multiplying polynomials is distributing, is FOILing, and if I have a trinomial times a binomial or a trinomial times a trinomial, then it's a kind of process like FOILing or like distributing, where I have to multiply each term here with each term here. Okay? All right. I hope this was something that helped those of you who are less comfortable get more comfortable. And those of you who are very comfortable, yeah, I don't know that you need to do the homework here because you're already very comfortable with it. Okay, assignment 15, done. And remember, assignment 15 is a textbook assignment, so if you're doing those textbook assignments, please make sure you get our scanned pages from Office 365. All right, have a great day, everybody.